The topic of this lecture will be solvents that can be used in nucleophilic substitution reactions. There are three classes of solvents. The first are called protic solvents. Protic solvents are solvents that contain acidic protons. Remember that acidic protons are protons that are attached to an electronegative element. Therefore, these solvents include ammonia, water, and alcohols. Protic solvents by necessity are polar solvents, and in this way they're good solvents for nucleophilic substitution reactions. Polar solvents are good for nucleophilic substitution reactions because the reactants for these reactions, the substrates and the nucleophiles, are also polar and sometimes charged. Because like dissolves like, these polar and/or charged substrates and nucleophiles are very soluble in protic solvents. Additionally, protic solvents can form hydrogen bonds to the nucleophile and the substrate to help solvate them. However, this hydrogen bonding and the level of solvation of the nucleophile can affect its nucleophilicity, and this can negatively impact nucleophilic substitution reactions as well. The reason for this is that a solvated nucleophile cannot react while it is solvated. Remember that solvation means that the solvent is coating the nucleophile in solvent molecules. In order to react, the nucleophile must shed those solvent molecules. Therefore, stronger solvation leads to a weaker nucleophile. Smaller nucleophilic ions or atoms are more strongly solvated. There are two reasons for this. First, the solvent can approach smaller ions or atoms more closely, and hydrogen bonds that are formed to smaller ions or atoms are stronger. What this does then is it enhances the trend that we normally see. Larger ions are better nucleophiles. This is even more true in protic solvents. The next class of solvent are polar aprotic solvents. These are polar solvents that do not contain an acidic proton. Examples include acetonitrile, dimethylformamide, and acetone. These make good solvents for nucleophilic substitution reactions because the polar substrates and nucleophiles are soluble in these polar solvents. Also, because they cannot form hydrogen bonds to the nucleophile, they don't affect the nucleophilicity. The final class of solvent are nonpolar aprotic solvents. Nonpolar aprotic solvents do not have acidic protons and they are nonpolar. Some examples of these include hexanes, benzene, and toluene. Because these solvents are aprotic, they do not affect nucleophilicity. However, they tend to make poor solvents for nucleophilic substitution reactions due to the low solubility of these reactants in these nonpolar solvents.